Based on the remainder theorem, we now have some tools that we can use to decide whether a given value is a zero of a certain polynomial function. However, are we just supposed to test random values for x until we find one that works? The Rational Zero Theorem helps us narrow down the potential zeros for any polynomial function. Recall that a polynomial function can be written in this form: descending powers of x, each with an accompanying coefficient. And the Rational Zero Theorem tells us that every rational zero of the function has the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. I can use this to list the possible rational zeros for a given function. In my example, the constant term is 1 and the leading coefficient is 2. And so the factors of 1 are positive or negative 1. The factors of 2 are positive or negative 1, positive or negative 2. Therefore, what are the possible zeros to this function? Well, it's any factors from the first list divided by any factors from the second list. So the possible zeros would be plus or minus 1 divided by plus or minus 1, or plus or minus 1 divided by plus or minus 2. We can simplify this quite a bit. So positive or negative 1 divided by positive or negative 1 is just positive or negative 1. And the second set of factors is positive or negative 1/2. These are the possible zeros for this polynomial function. We're not guaranteed that these are zeros, but these are our possibilities. Any zeros that exist will be from this list of values. Let's look at a final example where I actually find the rational zeros of a function using the Rational Zero Theorem plus a little bit of long division. First, let's identify the possible zeros to this function. The factors of negative 1, the constant term, again, are positive or negative 1. The factors of 4 are positive or negative 1, positive or negative 2, positive or negative 4. So the possible zeros would be plus or minus 1, plus or minus 1/2, plus or minus 1/4. Any actual zeros that exist are found on this list. So we can pick one just to try. Let's say we believe that there may be a zero at x equals 1. So we're going to test a zero of x equals 1. One way to do this is by taking its corresponding factor, x minus 1, and seeing whether that divides the polynomial function. I have 4x cubed minus 3x minus 1 divided by x minus 1. I'm going to leave a space here for x squared in my long division. And I carry out the long division. The first term is 4x squared. Then I subtract. We carry on. The next term is plus 4x. I multiply. 4x times x is 4x squared. 4x times negative 1 is minus 4x. And I subtract. Negative 3x plus 4x is 1x, so I get 1x minus 1, and the last term is positive 1. As I subtract, I see that there's a remainder of 0. And we recall that this remainder of 0 means x minus 1 is actually a factor, which means x equals 1 is a 0. So that guess worked out okay. It also allows us to rewrite the function. So 4x cubed minus 3x minus 1 equals x minus 1 times the quotient 4x squared plus 4x plus 1. And if I look at that quotient, it is now a quadratic, and I can factor that quadratic polynomial. It factors into two pieces, 2x plus 1 times 2x plus 1, or you could say it's equal to 2x plus 1 squared. So once we had a lead, we were able to use it to simplify our problem and to completely factor the polynomial function. What are the zeros for this function? The zeros are x equals 1 and x equals negative 1/2. This one has a multiplicity of 1. This one has a multiplicity of 2.